So yeah, let's kick off here. Hi guys, this is Chris from DoraHacks. Welcome to join the second workshop Building the Future for Cardano EMURGO X DoraHacks Hackathon. This is actually the very first time that DoraHacks support Cardano and EMURGO for the hackathon efforts. So it's definitely very exciting. This hackathon gonna have 3 tracks, which are derivatives, aggregator, and zero knowledge, with a chance to win up to 2 million prizes, including a 100K prize pool, and another rest of the 2 million prize will came as the potentially strategic investment grants or in other formats that are provided by EMURGO, DoraHacks, and Cardano. Yeah, so specifically for this workshop today, we're very happy to have 3 guests to join us, which are Naga from EMURGO as the community manager, Varderes, if I pronounce this right, from Maestro, and Jesper from Partisia Blockchain Foundations. Yeah, so Naga, why don't you start by a very quick self-intro?
Sure. Thanks, Chris. So I am Nagatoshi, the community manager for EMURGO. I am looking over the community for the Cardano EMURGO build 2023. And so far, the community is doing amazing. We are growing in numbers as always. So thank you, guys. Thank you, community, for always being very active. And we got a lot of things coming up for you guys, especially this is an amazing workshop that I'm looking forward to. I'm really excited about. So, I don't want to take too much of the show time. I'm very interested to know what Varderes and Jesper have in store for us. So, Varderes, do you want to do an introduction and take on the show?
Yeah, sure. Thanks, guys. Greetings from Austin, Texas. My name is Varderes. I'm the CTO and co-founder of Maestro, along with fellow co-founder and CEO Marvin. I have a background in physics and computer science, and then in my career, I've worked in many different industries, both as a researcher and engineer, namely biotech, aerospace engineering, and I'm now fully focused on crypto, blockchain, and helping build the financial future of the world. So really excited to be here and showcase the hard work our team has put into our dApp developer platform for Cardano, and also learn about what the community is up to and what they're working on, such as Jesper's Partisia project.
Thank you, Varderes. And Jesper, would you want to just give an introduction on?
Yes, I'll gladly do that. Yeah, my name is Jesper. I am with the Partisia Blockchain Foundation, and I'm the head of the smart contract team that is creating the whole ecosystem for creating smart contracts. Specifically, we're working on smart contracts for that allows you to do zero knowledge computation using MPC, which I'm looking forward to tell you about. My own background is mostly in computer science. I worked in consultancy for a number of years before I joined the exciting opportunity that is Partisia, with the ability to bring both multi-party computation and everything good that comes with it to the world. So I hope to convince you that this is a really good solution that will work well with the Cardano ecosystem.
Awesome. Thanks, Jesper, for that introduction. So without further ado, I think, Varderes, do you want to kick it off with your what we got from Maestro?
Yeah, absolutely.
Yeah. Cool.
All right. Yes.
Let me put this right through.
Great.
Yeah.
All right. So, yeah, like I said, I wanted to showcase Maestro's dApp developer platform for Cardano. So in case you haven't ever heard of us or you've never checked us out, in the Twitter world of Cardano, go to gomaestro.org, which is just our landing page, and it gives a really good kind of overview of all the different things we've built throughout the last year and a half. We initially started out as a stake pool provider for Cardano ISPOs. And then within the last year, we've kind of grown the vision into being a full-blown, complete dApp developer platform, in particular providing data APIs and event management APIs for people building on Cardano. So went from just running nodes to indexing the blockchain and trying to make it really easy for people to ramp up and build complex, large-scale applications and even smaller projects on Cardano without having to run and manage their own infrastructure. And so, if you look at other ecosystems, like Ethereum-based, EVM-based ecosystems, particularly, they all have very mature developer tooling and enterprise solutions for people that want to build and not have to run and manage their own infrastructure and index their own data. And so Maestro is really trying to solve that problem of making it really easy to build on Cardano and abstract away the complexities of building on Cardano. So I won't go into every single one of our products today. In particular, I want to talk more about our platform and give you a live demo of just simple queries that you can make to retrieve data that will be helpful to you when you're building dApps. And I also wanted to showcase our transaction manager. So our transaction manager allows you to be notified of state transitions associated with your transactions with simply having just all you have to do is simply submit that transaction to our API and then use your own webhook to listen on transaction events that you can then react to in your decentralized application. Okay, so to learn kind of much more deeply about what we've done, and this could take hours for me to talk about in depth, we have a documentation page, simply docs.gomaestro.org. And in here we talk about how to actually log into the platform, how to create API keys, how to use the transaction manager. We also go deep into our different products and kind of the vision of our infrastructure, and then also the specific products themselves. So how our indexer works, how we build an API around that indexer, as well as our transaction manager, and how we manage the states of your transactions in particular. And then in the very near future, we will be launching something called turbo transactions, which help propagate your transaction on chain, especially during times of high network load. And then we have some user guides that are very detailed around how to actually use the platform and how to understand the different data that's being returned to you. We have an API reference for the blockchain indexer. So this is going really deep into all of the different endpoints that you can use with specifically the indexer API. And a lot of these revolve around Cardano primitives, data that you would need when building a dApp, such as various data associated with UTXOs, associated with addresses, assets, general information such as the chain tip, and information about accounts. So and then we have a lot of specialty special sauce endpoints that are kind of aggregates around those, and we're going to continue to build more complex integrated verticals in the next year. So what now is a base layer data API will eventually be that plus aggregated data for analytics, data about NFT trades, data about the market of Cardano, and this is just this is what we have now. Is just getting started. We also have a Haskell SDK, which allows you to use the Maestro API, indexer API within a Haskell environment, and we are very close to releasing a TypeScript SDK, and then follow that we'll release both a Golang and a Rust, and eventually Python, and pretty much any well-known language. It's all on our radar. It's just a matter of prioritization and capacity. And then we released our beta about 7 weeks ago. So beta allows you to log into the platform. Let's log in here. And then I'll kind of jump in and show you how to do everything in particular. But The beta essentially was a reason for it was an opportunity for us to get our platform out there without any kind of subscription fee, and just really understand how people would want to use this, understand like what we need to scale on our end, what traffic peaks and types of data we need to optimize for. And it's been incredibly helpful. And in addition to this, right, so in addition to releasing a public beta that literally anyone could right now go log in and use, we also were very really integrated with the community in terms of getting the project out there, getting it in front of people, asking them to use it, test it out, and that has actually been incredibly helpful as well. So we have a very clear kind of path forward in terms of features that customers have asked us for, and it's given us a lot of guidance in terms of what the ecosystem currently needs. So this beta, although it was a very difficult process to get it out there, as anyone that's released an infra provider platform knows, it's given us a lot of direction, and it was well worth the effort. So I also want to say, before I jump into a live demo, that we will be releasing the full V1 platform around second week of June, and that will involve paid subscription tiers that give you much higher throughput and capacity for really like those heavy workloads that enterprise companies are interested in. And then furthermore, it'll give more features such as additional endpoints that we haven't yet released. And finally, our turbo transactions feature that I just mentioned earlier. So yeah, that's really it in terms of the background of Maestro and what the state of our platform currently. So here I have here just a simple dashboard, and it's if you've used any kind of infra provider for data, whether it be Web3 or Web2, they all have kind of they all have a similar design because of just how intuitive this type of design is in terms of you create a project, the project gives you an API key, and you then use that API key to access data that we provide. So I'll actually delete the one I have here. I'll just create a new one. So this is the platform which I logged into earlier. It goes straight to the primary dashboard. I'll just call this EMURGO demo. And then we'll select the pre-prod network. And I'm assuming people in this call mostly are familiar with Cardano and the networks. The pre-prod is just one of the test networks that I'm going to interact with today. And it generates for me an API key, which I'll just copy. And then I have here, just for simplicity, a Postman environment, which I use for like testing and demoing. And I have this API key, which I'm just going to pass in here. And this usually, if you're using curl commands or making REST API requests from your favorite, language or favorite framework, or even just using curl straight up curl, you just need to pass this into your header. And all of this is actually also explained in our docs. It's very easy. We have very clear get started guides that you can use in our docs page. So passing this API key, I'm just going to test a few of our queries. So one kind of popular one is chain tip. The chain tip just tells you currently in the pre-prod network the tip of the chain. So the slot number, the height, and then the block hash of the block at the tip right now. Some other ones we can test out. So maybe some more complex ones. Let's see. UTXO's address is also very useful when building transactions related to your dApp or related to just sending the payment to an address. And this basically just shows all of the UTXOs that are at that address that you can use as input to your new transaction. And many, many more examples here, which I won't walk through. It'll take a very long time. But nonetheless, for every app, some subset of these endpoints would be useful to you. And and so that's our blockchain indexer API in a quick nutshell. And want to then jump into now our transactions kind of flagship product. So we call it the transaction manager. It involves two things for now. Number one is the transaction monitoring. And so what this does is we go to transaction manager here. With basically the way we look at transactions on Maestro, and essentially how you could how it's implied on the blockchain itself, but the way we've kind of abstracted away the states ourselves is through what we call a state machine. And in that state machine, we have essentially 5 different states, right? So when you submit a transaction, right, it could immediately fail because there was a network issue, it couldn't reach the node. It could be rejected from the node's mempool because, well, it was invalid construction. It didn't have valid UTXOs, for example, or it wasn't balanced, right? So the node looks at that, introspects, and says, hey, this is invalid. I'm not even going to try to put it on chain. It could be pending, which means it was accepted into the mempool of the node, and then the hope is that it will eventually land on chain, though it could be accepted into the mempool, but then be rejected later. And then finally, if it has been, if it's pending and it's valid still, it could land on chain. And then because of the nature of Cardano being a UTXO-based blockchain, rollbacks are happening all the time, and your transaction could actually be rolled back. And any kind of infrastructure you're building for Cardano or UTXO-based blockchains, you have to account for rollbacks. And even if you're not using an infra provider and you're building a lot of this in-house, if you're building a single dApp and you want to build this, build some kind of transaction management in-house, you have to account for rollbacks. And so what we've done at Maestro is we've abstracted the rollback handling away from the developer. So all they have to do is just submit the transaction, and if there is a rollback, they will be notified. And if it's landed back on chain after the rollback, they will be notified as well. Yeah, so I'm going to, before I submit the transaction, if you want to interact with our transaction monitor, all you have to do is simply submit a transaction to our post transactions endpoint. And then we also have a submit TX endpoint, which is just a drop-in replacement for the IOG Cardano submit API that the whole community knows about. There is no monitoring when you use this endpoint. It's just an immediate drop-in replacement for anyone that wants to have a standard submission endpoint. And then transactions is also a drop-in replacement, but instead your transactions are monitored through Maestro. And so what I'm going to do is I'm going to just create a very simple transaction between 2 wallets. So I have here, we call it Maestro testing 1. I'm just going to send it some ADA from another transaction, from another wallet. Let's say 500 test ADA. By the way, can everyone still hear me okay from the hosts? Can you just notify me? Like, okay, great.
Yes.
Fantastic.
Yes, we can.
Cool.
Don't worry.
It's great. Yep. All right, so instead of submitting, I'm going to download this transaction. And so typically when you're building dApps on Cardano, you don't actually do it through Eternal and on the UI, right? You build the transaction in your tab, your application backend, Lucid or Mesh or wherever, or Atlas, in the case of Genius Yield. But this is just a quick way to build a transaction, not sign it and not submit it. So I have here a signed, not submitted transaction, and I'm going to just submit this through submit API of Maestro. The transactions endpoint of Maestro. I'm going to just very quickly create a binary stream of that transaction. And I just have a helper script here to help me with that. So this is just a file for the transaction with the C4 hex. And then I'm going to just output this where my Postman expected so that I could submit it through Postman. This will create a binary stream of the transaction that I just created in Eternal and signed, but did not submit. Okay, so last thing. So we want to be notified of our transaction states. So the way we do that is 2 ways you can do that in Maestro. You can simply go here after submitting and look at this dashboard, which I'll show you. And this will just list all of our transactions. Another way is to create a webhook. And so webhook is, let's see, EMURGO test. So this is an unopinionated way for you to receive notifications on your own webhook. So assuming you have some server running with a webhook URL, you can pass in that URL, and then we will post transaction state changes to that URL. So the way I quickly set that up in my local environment is using a really cool tool called ngrok. Ngrok is just kind of a opens a proxy to your local environment, and then it runs a server. So the proxy has a public URL that the world can access. And so I'm just going to create one, and it auto-generates the URL randomly. And then I'm just going to use that for this webhook in Maestro. So I'm going to save that webhook. It's active currently, and my ngrok is running. If you want to learn more about ngrok, very helpful with local development. I highly recommend looking at it. And so finally, I'm going to submit my transaction. So I have here Postman, and I have the monitor transactions post request set up, and it has my transaction that I created, the binary stream. It's already loaded into this environment. So I'm going to submit that transaction, and I already got a transaction hash here, which means that my transaction is pending. So that transaction that I just submitted is pending, but also let me open this thing, localhost 4040 here. So ngrok also has a very simple UI you can use to receive these webhook payloads that people are submitting, or whoever the system you're working with, and then it'll just show you the payload here. So I'm just going to wait for that here, and you can see here out the transaction still pending, and we then received a payload here saying that our transaction is now on chain. And so if we refresh this, we will actually see on chain here. It's been a little bit cool. And so yeah, this server that I'm running received the webhook that my transaction is on chain. And if I'm running this in a server somewhere, I'm listening for these webhook events, right? Let's say I'm building a dApps that is, involves trading of a liquidity pool. I have a transaction that I've submitted, and I want to know the state of that transaction. I can respond to this, I can capture this payload and update my UI or update my database accordingly. So it's very unopinionated around what you want to do with this payload, but it is clear set of notifications around your transactions, and you can react to them accordingly. So yeah, that's my quick demo for the transaction manager. And I wanted to encourage everyone to go to Maestro and please log in, give it a try. We're still in beta for another 2 to 3 weeks, but it would really help to really hit the system hard, try to break it, I guess. Well, don't try to destroy it, but hit it hard and give us some data that we can use to build a very powerful platform for the whole ecosystem, to really be a catalyst for the ecosystem. And yeah, that's my quick demo, and I hope that was informative. Happy to answer any questions if you guys have before I conclude my talk.
Thanks, Varderes. That was really insightful. Yeah, I think we don't really have many questions coming in at the moment, but maybe later on we probably do for the Q&A session. But they can go directly to your website and look into all these platforms. Is that correct? Is that what it is? This is your website. Is that correct? Yeah.
Yes. Yeah. So that's the main page, and then from there they'll see the dApp platform, and then in that dApp platform page they can log in, and then they'll be redirected to the dashboard where they can create API keys and the webhooks.
Awesome.
Mm-hmm.
Cool. So if anyone's interested, please have a go at gomaestro.org. That's the website right there. And of course, if you guys have any questions, put it through our Discord or anything. I can definitely ask for Varderes later on for any questions, clarities you guys need on that. So yeah, cool. Thanks for that, Varderes. And I think next up is Jesper. How are you, Jesper? Are you still there?
Yes, of course. I'm still here. And thank you, Varderes.
You're welcome. Good luck. Yep.
Thank you. Let me add your stream.
Yeah, that'd be great. Thanks a bunch. Yeah, well, I'm going to tell you a little bit about how you can use multi-party computation to achieve, well, privacy in a blockchain setting, and how you can use the Partisia blockchain as a second layer to actually layer that on top of other blockchains, like, for instance, Cardano. So, but let me first share some of the topics that I'll be talking about. So I'll tell you a little bit about what Partisia blockchain actually is, how we got started. Then I'll talk about the secure multi-party computation and how that works. I'll touch upon how zero-knowledge computation and CK proofs are related and how they're not related. I'll talk about balancing privacy and transparency, and finally I'll give an example of how you can use the Partisia multi-party computation as a second layer on top of other blockchains. So first, a little bit about the Partisia blockchain. All the way back in the 70s and 80s, Ivan Damgaard actually started working on cryptography here in Aarhus, where I'm also at the moment. And he laid some of the foundational methods that are being used in cryptography. And actually, if you look at it, then he kind of both laid at the foundation that is underlying blockchains, but also foundations for multi-party computation, which is a method that can be used to compute on data without actually knowing what the data you're computing on is. So Partisia blockchain was born out of these cryptographic methods and the environment of cryptographers that work in Aarhus. And the purpose of Partisia blockchain is to provide a solution where you can actually compute on data in private while still getting all the advantages of a blockchain. So we have a bunch of projects already running. For instance, I can point to the International Red Cross that we're helping build some humanitarian token solution for, where you can actually have private tokens. We have inside networks where people are sharing their data, but actually getting something back for the data they're sharing. And we have a bunch of other solutions as well. So what I want to share with you today is, what is secure multi-party computation? How does it actually work? And how can you use that in your own applications by creating solutions that use multi-party computation and put that on top of another blockchain solution. So I'll start by giving you some sort of intuition about multi-party computation. The overall idea is actually pretty simple, even though this slide might look a bit complicated. It's actually pretty simple. So the intuition here is that we want to calculate the average salary of 3 people, and you can see these 3 people. They have one has a salary of 4,000 euros, one has a salary of 2,700 euros, and one has a salary of 2,300 euros. And we would like to compute the average, but we would like to do it in a way where none of them actually have to reveal to each other what their salary is. So the method that can be used is, if each person actually takes 3 cards and puts a random number on each of the cards, but the sum of the numbers is actually their salary. And then they exchange those cards in such a way that they give 1 card to each of the other 2 people. Then those 2 participants will not know what their salary is, but they will have a number that is a part of the salary. And that means that each of the persons now have 3 cards with a number on it. And if they are willing to add up these numbers and share the sums, then it is actually possible for us to calculate the average, even though none of the people learned the salaries of the other persons. So that's kind of the intuitive idea about how you can actually do computation on data that where you do not have insight into what the data actually is, but you can still arrive at a result that kind of aggregates those data up. What we are doing Partisia Blockchain and with the MPC solution that we're providing is that instead of people having to share these different cards with each other, well, then we are providing an infrastructure that allows you to get access to servers that will do the computation for you. So by deploying to the Partisia blockchain, you can get some CK nodes allocated. When you want to do some sort of computation, then you can split your data into a number of shares, just like the 3 cards. You can send 1 share to each of the servers that were allocated, and those servers will then perform the computation that was programmed into the smart contract. So that is the intuitive idea about what we are providing. In practice, what actually happens is, of course, that a bunch of math and crypto goes into the solution. So it is not cards that are exchanged, and it is not just taking random numbers that add up to a specific value. The cryptographic math instead allows you to do secret sharing in a way where you can take any type of secret, even of very complicated data, and share them in a secure way where no other participants and none of the participating nodes that are doing the computation will learn anything about the data. The crypto also allows you to perform arbitrary computations and not only do averages. In fact, you can actually program any computation that you want to happen, and then the nodes can perform that computation. And finally, it allows us to actually verify that everyone, both the users and the nodes that are participating in this computation, follow the protocol for actually doing the sharing, doing the computation, and only revealing the result of the computation and not any parts of it. So this entire domain of math has kind of been developed and created for this exact purpose of creating multi-party computation on top of blockchain. So just to dig one step deeper, I'll tell you what happens when you actually put a smart contract on Partisia blockchain that has some CK parts in it. When you deploy the contract on the blockchain, then a number of nodes are allocated to participate in the computation that you want to run. These nodes are actually required to stake a bunch of tokens as collateral to participate in the computation, and that collateral is there to as part of the trust model. So for the nodes to actually participate, they have to stake the collateral. If at any point the node, for instance, decides to stop being part of the computation, then you as the contract owner will be refunded from that collateral. When the contract has been deployed, then you have a CK contract running on the blockchain. And that contract will work in 2 parts. First up, there will be a public smart contract that orchestrates everything about how the computation actually works. So that is receiving the input, deciding when the computation starts, deciding what happens with the result. The actual users that participate in whatever you're computing, they can deliver their secrets as shares directly to the nodes that were allocated. The nodes can perform arbitrary computations on the secret share data, and during that computation they will gain no knowledge about the inputs and no knowledge about any of the intermediate outputs. And when a computation has been completed, the result is actually still a secret, but the contract can choose to reveal the result. And in the average salary example that I presented earlier, the contract would, for instance, work in this way where you deploy the contract, the users input their different salaries, the nodes compute the average, and then the contract choose to reveal what the average is. So to dig even one step further down, then this kind of illustrates what goes on when you put a CK contract on the blockchain. So the smart contract has two pieces of code. There's one piece of code that is the orchestration code, which is runs on the actual blockchain. It orchestrates everything that goes on, so it can perform any public computation. It can accept or reject any input that is delivered to the contract. It decides when the computation is started, and it is the public part of the contract that decides when outputs are revealed. The other piece of code is the CK computation that is executed by the CK nodes. So when the contract is deployed, as I said, the blockchain will allocate a number of nodes for your computation. Those nodes will then become a CK group, and they will keep track of whatever is happening in this one computation. These CK nodes gather up all the inputs from the users, and when the public contract starts the computation, they then execute the computation that they were programmed to do. And the actual computation that is executed is smart contract code, meaning that it's completely visible on the blockchain. So users that are interacting with a CK smart contract, they can choose to do different things. They can either call a public action on the public contract, they can deliver a secret input, or they can actually fetch their own secrets if an output of the computation was designated to a specific user. So this pretty strong model allows you to create arbitrary kinds of contracts where you do the orchestrations on the blockchain, and you can perform the actual computations on secret data that is kept secret both from all of the users, from anyone who's monitoring the blockchain, but also from the actual nodes that are running the computation as part of this MPC group. I would like to show you what an actual contract looks like, because this entire setup with the blockchain, with the CK nodes, and with the public and the private smart contract actually allows you to obtain programmable zero-knowledge computation and orchestration. So on the left side here, what I'm showing you is a small part of one of our example contracts. That is a contract that allows you to perform a vote. So you deploy the voting contract to the blockchain, and you have a bunch of users that can then be allowed to deliver votes. Each vote is a secret, and when a deadline occurs, the votes can be counted. So what you see on the left here is actually the program that performs the counting of the votes. And this part of the computation runs on the CK nodes. So the computation is running without anyone actually knowing any of the intermediate results or any of the inputs. So as you can see, the CK compute function here starts by initializing an SBI 32 to 0, and SBI 32 means secret binary integer with 32 bits. So now we have a secret number that we know is 0, so it's not that secret. But what we then do is we iterate over all the secret data that we have received, and for each of those data, we look at whether they are equal to 0, and if they are not equal to 0, we add one more to the number of votes. And at the end, we return the number of votes. So if this was executed in open, of course, anyone who was following the execution would be able to see exactly which votes were for and which were against. But since this is executed on secret shared data, what actually happens is that each of the nodes do not know whether the vote is for or against. Instead, the crypto ensures that we can still do this computation by actually doing the comparison and adding up the number of votes without knowing whether we are adding 1 or 0 at any given time. And at the end, we have the resulting number of votes, and that piece of data can then be revealed. On the right side, you see part of the orchestration. And the orchestration of the contract here is, what I'm showing here is how do you actually start the counting of the votes. So other parts of this contract will be controlling what happens when you deploy the contract, what happens when someone tries to deliver a vote, and what happens when we are done with the counting. But I've just included the part here where you can actually start the counting. And what you see here is also pretty ordinary code that kind of receives the action that is the start of the counting. Then the smart contract checks whether or not the deadline has been reached or not. If the deadline that has been programmed in has not been reached, then the transaction will fail and the counting will not be started. If the deadline has been reached, then we instruct the CK node to start the computation. And we also instruct them that the result that we're expecting is of the type that we want to know how many votes were actually cast for yes. And this part at the bottom is the instruction needed to actually start the computation. Then the nodes will run the computation on the left, and the result will be, the control will be handed back to the orchestration, which can then do something with the result. In our example here, what the orchestration will do is take that result, reveal it, and publish it as part of the public state of the contract. So as you can see here, the code both for the orchestration and the computation is ordinary code, and in this case it is programmed, all of it in Rust. So if you can code Rust, and that is pretty learnable, then you can create programs that will run on secret shared data with Partisia. All of this is only possible because the blockchain has been built on the architecture where a bunch of the nodes running the blockchain are also willing to run as CK nodes. And the job that they are solving is that they are performing the privacy-preserving computations. They are staking collateral while running a computation towards running it. They are helping produce what is called pre-processed material. That is something that is necessary to actually run. That's part of the cryptography that's necessary to run a CK computation. And then they will run the actual computations. And the payment of these nodes is done in the shape of gas, like any smart contract. But on Partisia blockchain, you have the special situation where the gas is actually not the native currency. It is currencies from other blockchains. So you can bring your own coin from a bunch of other blockchains, and then you can pay for performing your computation on Partisia with the currency of other blockchains. So a few words about MPC or CK computation, because as you probably saw from what I presented here, then it is not the same as CK proofs. What you get with a CK proof or a CK snark is that one user or person, the prover, can create a proof that can then be published or sent to someone else, and then another person or user is able to verify that that proof is, if that proof is true. So what the proof will allow you to get as input is data from one party or publicly known information. And as output as the verifier, the output you can get is true or false to whether or not the proof is valid or not. So you can verify this one property about something. CK proofs is very useful when you're trying to prove some property, but they are limited to only these yes and no answers for specific properties. While the MPC that we are providing is actually a more general or Turing complete solution where you can program any type of computation on inputs from many parties, and you can choose as the programmer exactly which results are revealed and which are kept secret. So you can perform very complicated computations, and then you can reveal only the results you choose to reveal. So you can take input from many parties, and you can create any result as long as it is computable with a normal program based on the inputs. So yeah, so essentially zero knowledge proof is a subset of zero knowledge computation. This also means that the MPC solution is designed for arbitrary public and private coordination, and not just one of the two. So we kind of have two layers on purpose. We're working with the public part as a solution that can be used for transparency, meaning that you can provide information, transparent information to anyone that you wish to show transparent information to. This is one of the big strengths of blockchain in general. But we also have this private zero-knowledge computation layer that allows you to keep the information private that you wish to keep private. So you can have a 100% public application that is where everything is public, and the whole state is visible on the blockchain, and all transactions are visible with the information about who sent them and what they sent and what the result was of running the public application. Maybe you want to do 100% private applications where every transaction is private, and where you use the private zero-knowledge computation layer to compute on private data. Maybe you want to create anonymous applications where the transactions are public, but the zero-knowledge computation can be used to keep people or their data anonymous. Or maybe you want to mix and match, where you keep some information private forever. You reveal some information after some time, and you can perform any computation to actually reveal what you wish when you wish to. This is can be very useful if you, for instance, are hit by some sort of regulation where you are required to compute or reveal some information to authorities. It can be useful if you're running time-sensitive processes where you want to keep secrets for a while and then reveal results of computations. And with the solution that Partisia offers, then you as the programmer who creates the smart contracts are in control of what is private, what is public, and which computations are performed and which information becomes public when. Finally, some words on how you can use this as a second layer solution. I think this gives an overview where you can kind of see that, yeah, on any blockchain, you could run your public smart contracts and do your transactions, and then you could use Partisia just for CK as a service, meaning that you deploy the private part of the smart contract on Partisia, and you keep the public part of the contract primarily on the other blockchain. And the users that are then interacting with these smart contracts would be interacting with the layer 1 blockchain for the public parts and with Partisia for the private parts. But the results of any computations would be mirrored to the other blockchain to make sure that whatever result comes out of the computation is then mirrored onto the blockchain where you need to actually act on the result. So if I put a little more detail to that, I've created an example here where the blockchain in question would be Cardano. So you would be deploying a smart contract on the layer 1 blockchain, Cardano, that actually does whatever public computation keeps track of the public state, and that has to act on the result of whatever happens in the MPC computation. Whatever requirements you have for the user input validation would be copied to the private smart contract that is then deployed on the Partisia blockchain. The users will be delivering their input on the one hand to the public parts of the input to the public smart contract on Cardano, but the private inputs would be delivered on Partisia directly to the CK nodes that were allocated for that computation. The CK nodes that were allocated, what we do is that we take their public keys and we upload them to the contract on Cardano on the layer 1 blockchain. And this will allow the CK nodes to actually sign off on the result of the computation when they have completed the computation. So the entire MPC computation can run on Partisia blockchain as a layer 2. The contract receives the input. The computation is executed whenever the requirements are fulfilled. When the computation is complete, the result can be revealed. The MPC nodes can sign the result using their private keys. The signed result can be moved back to the layer 1 where it can then be verified that the result was actually produced by the MPC nodes on the layer 2. This will allow the smart contract on layer 1 to be certain that the result was actually produced by the MPC computation and by the smart contract deployed on Partisia, and will therefore allow the layer 1 to act on the result that came out of the MPC computation. So this was a brief overview of how you would structure a layer 2 solution to actually get MPC computation running on top of your layer 1 solutions today. If you want to see more about how you can actually create these solutions, then you should go to partisiablockchain.com. We have a bunch of documentation there and examples that will allow you to actually see more about how to do this and try it out in practice. And hopefully you will storm there and start creating solutions that use MPC and make your solution stronger.
Wow, thank you, Jesper. That was an amazing show for Partisia, and for me, zero knowledge is definitely a new thing. I'm nowhere technical as you are, and I will try not to embarrass myself, but I do want to ask, and maybe you have brought this up, but what are the underlying technologies, or I would say techniques that are used in the zero knowledge nodes? Like, how do you, what goes behind it? I'm just curious as to.
So underneath this, as I kind of alluded to in the presentation, there is a bunch of math going on. I think if some of the math is actually pretty well known, and if you're kind of in this MPC space, but what for the actual secret sharing, a technique that is called Shamir secret sharing is used for taking any information and then splitting it into shares that are each completely random noise to the node that receives it, but together they actually represent the data that you put in there. So that's kind of one technique for secret sharing. And to the actual computation, an MPC protocol has been specially developed for the Partisia blockchain that is called REAL. And that protocol is what allows us both to perform any computation, but also to verify that all participants are following the protocol. So if at any point there's a suspicion that someone is not following the protocol, it actually gives enough information on the blockchain to kind of unravel every step of the protocol and make sure that to see whether someone was actually following it or not. So it is a specially developed protocol for doing this type of MPC computation.
Okay. Yeah. No. Absolutely.
Yeah,
No,
that's
I was just curious as to what's behind.
course.
So no, of course.
And that's one of the advantages we have from having the close cooperation with the cryptographers who kind of help us create these solutions.
Awesome.
But I'd say as someone who's actually creating these solutions and deploying them on the blockchain, then you don't need to know all this stuff, because as I showed you, it is actually just a matter of writing pretty simple code that, for instance, adds up numbers or counts stuff or does whatever computation you want to do, and then underneath the hood, our compiler will convert that to the maths that is necessary to actually run on these MPC nodes. So as a programmer, you can use this without having to understand the crypto that goes into it.
Got it. Of course. One thing I wanted to ask you, and before we, if there are any questions from the members, and I'll let you know, but just for my sake, I know you mentioned about the example of the salaries. You were saying, you were showing different sort of ways of not knowing the salaries and somehow coming to an average thing. But in real world, where do you see an implementation or utilization of the real world application of zero knowledge nodes and the applications in Partisia blockchain?
Yeah, I think there are many potential applications for zero knowledge computation, because there's a lot of stuff that you don't want everyone to know, and there are a lot of solutions in the blockchain space that is kind of held back by the fact that everything is public. So I think in any situation where people who are participating in something would prefer their data to not be completely public, then you need some solution to protect that data. And there are solutions for that. Of course, there are also existing solutions for that. I think what MPC brings to the table is flexibility in you actually creating smart contracts where you decide, as the person putting this on the blockchain, what do you want to keep secret, what do you want to reveal, and when. So there are a bunch of use cases. I think the average salary that is only a real use case for a very, 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 very limited number of people. But of course, the voting example is a very real example where you want to actually have secret votes, but you want to make sure that the process is followed. Every person only votes once, and we get an accurate count. Auctions are a great example for actually running an auction where the bids are secret, and only after the auction has ended, you will find the winner, and then maybe you will reveal who won the auction and what the price was. You can do much more complicated setups like what I described, where you can have token contracts where the actual balances of each owner, each person who's holding a balance, is actually secret. So when you perform transfers, the transfer is a secret as well. But underneath everything, the balances is of course real numbers, but they are kept secret by the MPC. You could also, a very simple use case is avoiding front running in swaps. So if you can just keep the actual swap that you're doing, which direction it is in and what amount you're trying to swap between two tokens, if you can keep that secret for long enough, just until the swap is actually locked in, then it becomes impossible to front run, even for the nodes executing the swap. So that's a very simple scenario where keeping something secret, even just for a short while, is actually a very great advantage, because it prevents others from acting on that information.
And thank you for that. And I was checking your white paper, and I just came across your whole roadmap. It's absolutely amazing. Just wanted to ask, what phase are you in? Are we in phase 4 right now of your roadmap, or we're for Partisia?
Yeah, currently in our roadmap, we have mainnet is live at the moment, and we are so right now you can create and deploy these solutions already. We still have some things in the pipeline where we are kind of making things better and stronger, of course, but everything is live, and the whole development environment and everything you need to deploy these types of solutions is already running. We have all the development tools, we have the documentation, we have the examples, we have a testnet that you can use. So I think currently where we are is that everything is up and running, but we are still adding a lot of great stuff. One of the things we have in the roadmap, for instance, is the bridge to Cardano that will allow you to use the native currency of Cardano as gas on our blockchain. So you can bring Cardano's currency as bring your own coin. And that's one of the things that's still in our roadmap.
Awesome. Cool. No, just wanted to have a few questions. I mean, of course, your white paper is very, very detailed, and I was just looking through it. It's very interesting. So if anybody, I'm sure everyone knows where the white paper is, but if not, then there's the website I can share you. But it's on their website. You guys can check it out. It's just down there. But yeah, absolutely. Thank you, Jesper, for coming in and sharing a bit of ZK knowledge. Zero knowledge information to us, and it was absolutely amazing. And a lot of people obviously in our hackathon are asking, like, you know, if they venture into ZK knowledge, let's say route, what is one from your side, what would be one advice you would give, you know, the participants who are going down that route, you know, for
I think my advice to kind of get started with this would be to start. I think for me personally, at least, I think the first step was kind of accepting that it actually works and seeing for yourself that it works. So I think a really good way to get started is actually by trying out some of the examples that are pre-packaged, to actually try them out on the testnet, try to play with them and see that how it works, to get a feel for it. And then I think if you want to dig in, it is a very deep hole. You can dig as deep as you want, but there is a lot you can do without having to understand the maths. So I would definitely start with the examples, and then try to modify them and try to see if you can make them do what you want to get them to do.
Thank you for that advice. So there you go, guys, straight from Jesper himself. Hopefully a lot of people, we should be seeing a lot of people going into zero knowledge. It's one of the big you know, routes that a lot of people have chosen. So let's see what we get for the end of the hackathon. But thank you, Jesper, for coming in. And just like anything, you know, we just love to have a lot of participants coming in. We have got a lot of people showing up. At one point there were 10 viewers or 20 viewers. So yeah, thank you very much, everyone, for coming in. If there's any questions for Maestro or Partisia Blockchain, please, if you haven't had the chance to view it right now and ask, go to our Discord, you know, just ask away, and we will make sure that the questions are revert to Jesper and Varderes. So definitely on that. So thank you again, and let's thank you for coming in, and we'll catch up soon. Thank you, guys. Thank you for
viewing. Thank you for letting me be here.
Thank you. Our pleasure. Thank you. Take care.
You too.
Take care.